I wanted to upload a video on the channel to show that I'm still active. It's just that a lot of projects have been on standby. Has been a busy year with work and there was no time for repairing hi-fi. I just got a friend that gave me a hi-fi set that had a couple of problems, and I thought this might be a good opportunity to get my hands back on recapping hi-fi. And this video is a little bit to show that, well, some hi-fi is not really worth repairing, but it can be still good for rehearsing and practicing with the soldering iron and getting your fingers and your skills derusted. So here what we see is an amplifier, SONY amplifier, a very cheap one. As you see from the title, a TA-FE 310 with remote control. Now it doesn't include the remote control. I thought I'd give you a couple of hints of what has happened here and why exactly sometimes very cheap hi-fi is a great opportunity to exercise your soldering skills and making sure that you sort of don't forget a couple of things to do right, because as a matter of fact I've done something wrong here by trying to go faster than normally. So you will see here that I normally take notes of which capacitors I find, and quite often I also take a drawing. Not in this page, let me see, here I have a page, circuit board, just very schematic. This is from the CD player from the same set, the Sony set, and this is the circuit board, and I've just identified the caps, which direction the negative pole of the capacitor, and what are the specifications. But CD player aside, going back to the amplifier. So what we have here is really the cheapest amplifier that I had in my hands. I think I never had such bad... I've been working with dioxide for quite some time, and I've been cleaning. So here in the front there is the bass, treble, balance, and I think I've never had that dioxide after the treatment still feels so bad. The potentiometers, they must be really cheap, that after the treatment they don't have a good feeling. Two of them feel now scratchy. It's like I've removed the oil, the original oil. The original oil, by the way, well, it wasn't oil. I think it was more like a grease. And they were really tight, very stuck, because the grease had become very hard. So I had to clean it with dioxide, otherwise it didn't have a good feeling. And well, right now they twist better. So dioxide did its job. They are probably going to scratch way less. We will see in a moment. However, they feel now dry, and I never had that with dioxide. Maybe the fault is mine. Maybe I didn't shake the jar. That could be another reason. So again, as you see, it's good to to de-rust your skills before going to work on your real hi-fi. Now, just in rare case that you are in this video because you're going to repair one of these amplifiers or a member of its family, here in this circuit board in the standby there is one capacitor. Let me think. Yeah, on this side I put a slightly larger one. That's because it can hold a bit more voltage. This is a 35 volt and the original one was a 25 volt from Elna, as a matter of fact. I think I still have it here, yeah. Yeah, very good capacitor from Elna. Probably the only good capacitor in the whole amplifier, because all the others are very standard quality from Nichicon or Chemicon. So yeah, remember to probably change that capacitor because it can give you problems with the standby. And where it went wrong, and that is this video about, is here in the control board. So it's a very long board that has all the potentiometers also on circuit boards that have then pins. I don't know if you can see it in the camera. No, the camera is not picking it up. But so these circuit boards are connected with, so they are soldered on the other board. Same here, you see it has some pin connector that is also connecting that board with the main board. All really very cheaply done. It's really not suitable for repairing. But well, the thing is, I took all the screws, quite a lot. There is really a lot of screws because also the power button and the headphone jack in the lower part, the headphone jack has already 3 screws. Sony did spend more money on the screws than on the quality of the amplifier, in all honesty. Another 2 screws in the power, and the main board has another 5 or 6 screws, really a lot. And let me see. Yeah, that on the, oh yeah, on the board. So there are 2 capacitors here, just on top of the input switch. To control a 2 capacitors that are related to the controller chip. I hope that they are the remote control, which I don't happen to have for these amplifiers. I'm now gonna set it all back to test it, because the mistake that I did is the 2 capacitors were both very close to each other, and I had assumed that they were both 0.1 microfarad. Turns out quite often when I'm desoldering, I throw the capacitors that I've left here on this mat. I bought one of these mats for... But by the way, be careful, because some of these mats can have a magnetic strip in the back. This one has. So I only put here the capacitors, etc., that I will no longer use. I never put here on top anything that I'm going to use in the amplifier, because that magnetic strip, I don't know if it will influence the capacitors itself and magnetize them. So that's why I only put the old capacitors that go out of the amplifier. And so quite often I check them visually again to make sure, like double check, triple check, that I've replaced the correct ones. And then I discovered that actually one was 0.1 microfarad, the other one was 1 microfarad on that controller chip. And now there are two capacitors of 0.1 microfarad. So one of them is not the right capacitance, and that might be giving problems in the input selection. Well, we will see now in a moment when I test it. Then further, there are 3 capacitors here for balance, treble, and bass. Very typical that you will find some capacitors there to soften. I think that they are used to soften the effect when you move from one to the other side of the potentiometers. And then to finish the video, let's talk about a little bit of the main board. Actually, this is a main board that will be very comfortable to work on, because the heatsink is connected with this metal strip in the lower part. So it's very rigid, very easy to manipulate now that it is out of the amplifier. So I think I haven't changed the capacitors here. As you see, that I've all marked them for replacement. Haven't started on this board. It's fully operational. There is nothing wrong with the board. Well, yeah, there is something wrong with the board, and that is that it sounds terrible. Really, the sound is horrible via the speakers, very muffled. But via the headphones, strangely enough, the sound is okayish. But yeah, so all capacitors all have to be replaced. And I think I've never worked on an amplifier with such small capacitors for the power output. They are 4700. The original ones are 42 volt. I found these ones of 50 volts. So actually this one is slightly more rugged than the ones that it has. And honestly, I don't have any other amplifier with such small capacitors. They are all much bigger, more capacity and more rugged. These are really small. You might not see it in the camera, but here in real life, I don't think I've seen any amplifier with such small capacitors. And yeah, what else to say? A lot of variants of capacitors. I took notes, and I think there is probably more than 10 different capacitance across the different models types of capacitors. I'm not even going to bother to change the phono output. I don't expect this amplifier to even sound good for the phono input, so I'm probably going to leave the old ones and use this more like a backup or maybe as an amplifier that I can give to friends to use while I repair the main amplifier that they might have and want to change. Look at the cables. These are the cables that go to the speaker terminals. And this is one of the things that they quite often say on internet. Why bother putting very good quality speaker cable on an amplifier that is cheap? Well, these are some of the reasons, because as you see here, these cables are nothing. They are just so thin. The maximum current that these cables will hold is just, ridiculous low. So if you put a thick, very proper cable on this amplifier, well, sorry to say, but your funnel is here. This is the cable that will give you the limit of the current that this amplifier can pass on, which, well, shouldn't surprise anybody, because this isn't a powerful amplifier at all. That can be seen already from the capacitors. So yeah, this main board will now go back in the chassis, and I will test how problematic it is that I made a mistake. And you might say, like, well, if you know that you made a mistake, why don't you change it? Well, because I don't remember if it was the left one or the right one that was of 10 microfarad. Now, I could, of course, change them both for, 1 microfarad. I could change them both for 1 microfarad, but that can give other type of problems to the chip. So it doesn't matter, the mistake that I've made will influence the chip in one way or another. Actually, if I put them both from 1 microfarad, I risk to burn the chip, so that will be even worse. Right now, it's more likely that it will give some controlling problems because it doesn't receive enough current. The impulse current will be too small when it does some operations. Well, and with that, I hope that you keep watching or keep on the notification of these channels, because I hope in the future to have more interesting projects.